Yeah, good afternoon. So, in the previous class, we have seen databases and their characteristics, and what are the different kinds of characteristics of database, and what are the advantages, disadvantages have been seen in the previous class. And today, the advantages of database systems also taken. And today, I'd like to concentrate on so what are the different kinds of activities which have been available with the database management systems will be concentrated. And the second one is we go through the class, so basic definitions of your database and the database architecture, how the database will be defined. If possible, three schema architecture. So in three schema architecture, so you could also cover with data independence. So these are the three topics I would like to concentrate it today. So without any further delay, let's get started. So you can see basic definitions in the sense what is data, what is database, metadata, and all those things. So let us consider here. So database is basically collection. Sorry, data is basically collection of interrelated and known facts of so one particular item. So you can consider anything, whatever the system it might be. So that system could be taken into consideration by a collection of interrelated items, and those items or those facts must be known to everybody. So such kind of known facts will be interrelated. Known facts will be considered as data. Actually, data is a plural word. Plural. So plural word in the sense. So data could be taken. Collection of items actually. Collection of raw facts actually. So these collection of raw facts will be always concentrated or taken into consideration by all users will be called as data here. Then followed by, so data will be seen something like this: any student name, and then employee ID or employee salary, or so student registered number. I have given some 3 to 4 items here, which are related to different systems. So 2 are related to this one, and this one is related to students, and this one, and followed by this one is related to, so these 2 will be related to employee. So we have given some example. Okay, so data will be seen in such a way in this collection. So student related items are student name and student register number. Both are known facts only. Employee ID, employee salary are both are so known facts only. Something like this. If you collect so in such a particular order, then they will be considered as data, for example. And we'll go through this particular data very clearly in unit number 2. Then so data that could be defines same data will be called as metadata. Data about data. So here, employee student name, we don't know what kind of data it could be taken. What kind of data in the sense, what is the purpose of data which is being taken, whether it is taken all characters or numbers or dates, what kind of data which will be taken, we don't have any information. Employee salary also, it doesn't have any description. What kind of data it could be taken, doesn't have any description. Something like this, so will be called as data. And if you define what kind of data will be taken by one particular column or one particular item, then that is called as metadata. Yeah. So for example, metadata will be seen to something like this. Employee is actually our actual database name, and employee number. So look at this employee ID, which will be taken. So number of two numbers will be, 0299. You are able to take this particular thing, and there is a constraint, a restriction will be imposed on that particular employee ID. We don't know what is this primary key as of now. We'll come to know about this particular primary key probably after some 5 to 6 classes. Okay. However, employee name, so it could be taken all characters and it must not be taken any null values. Similarly, designation, similarly, employee salary. Employee salary, so it would be seen something like this. It is not null and check. So while enter data into this particular employee salary field, it must be in between these two. I mean, greater than or equal to 1,000 and less than or equal to 10,000. Only this particular data, I mean, this particular, these values can only be entered into that particular column. So this whole definition will be called as, this complete definition is called as, this whole definition is called as metadata. This is the metadata definition. So you have to define what kind of data which is going to taken by one particular data will be called as, means data about data. Data about data in the sense, so the description of each and every item, the description of each and every item will be considered as a metadata. And this metadata is very, very important while so creating any database scheme. So what is that schema? We'd like to discuss what is the schema in future, probably by tomorrow's class we'll discuss what is schema and what is occurrence, what is record, everything will be gets discussed by tomorrow. However, this is what about the metadata. And then followed by, so now we'll consider as a database. What is the definition for database? Database is a collection of related data. Okay, related data, and this particular related data must be stored in auxiliary storage device with the minimum redundancy. So redundancy in the sense you could right now you could not understand what exactly the redundancy will be. So redundancy in the sense, as far as the dictionary, the meaning for redundancy is repetition. So without any repetition, if you are supposed to store the data in any auxiliary storage device, such kind of a collection will be called as database. And this particular database, what is the major purpose of this particular database here is, it must be useful for efficient searching. It must be useful for efficient retrieval. Data will be retrieved from database at very less time. And if you want to update something, yes, it must be done efficiently. And if any data wants to delete, that particular thing also be done efficiently. So all these 4 operations, searching, retrieving, updating, and inserting will be done very efficiently. If such kind of things will be there, then so those operations will be done on that particular database. Then such kind of organization or such kind of what you call arrangement will be called as the database. It must be collect interrelated data. Data must be interrelated, and it must be stored the database data in the auxiliary storage, that is hard disk or magnetic tapes. However, whatever the auxiliary storage it might be, so on auxiliary storage with the minimum redundancy. So repetitions could not be there. Followed by so search operation and a retrieval operation and update, delete, and insert operations must be done in a proper way, in a particular proper way. So efficiently, and it could be done at a proper way. So such kind of items are called as databases. Okay. So we'll see each and everything probably by day after tomorrow, next class, probably by 5th class, we'll see everything. Now, how this example could be seen. So the representation of a database in literature of DBMS, it could be seen in such a way. Student of, student ID, student name, post join, fee paid, and the date of join, something like this. If you take one more thing, so that is employee ID, and so on and so forth. Okay, you can take something like this. Okay, this is what the database will be. If you want to store the data, yes, it could be stored very easily. If you want to retrieve the data, yes, it could be done very easily by using database application. Okay, then followed by DBMS. What actually the DBMS is? DBMS is a collection of programs which could be perform all these operations in the sense. So insertions, deletions, searching, and retrieval, everything will be done by a collection of programs, and such kind of programs, collection of programs is known as the database management system. It is actually an application program. So application collection of programs. These are not system programs. These are application programs. These will be always used to maintain the data in a proper way. Maintenance in the sense, so all these operations, whatever the operations I have discussed just before, those operations will be done in a proper way. So that is why it is called as a database management system. Okay, and this particular database will be always used to already what I have just before I have conveyed, same kind of operations. So the process of defining data and constructing the data and manipulating the data or manipulating the database will be called as database management systems. Okay, so these definitions, with these definitions, we have to conclude that the basic definitions here: what is data, what is metadata, what is database, and what is database management system. And as far as so database management systems, today we have for many applications. So number one, Oracle. Oracle is one company which is being prepared one database management system application, and then ProStage SQL. So PSQL, ProStage SQL. This is one more company, and then NoSQL, NoSQL. So this is also one more company, and then if you consider so Cassandra is one more company which is being maintaining object-oriented databases. Something like this, we do have approximately 125 different kinds of application programs are there, which are used to maintain whatever the discussions so far we made. So retrieval or searching or update, everything will be done by using these. So MongoDB. So several number of database applications are there here. Okay. Then followed by architecture. How the database architecture will be. So let us see very clearly. Let us see at the outer layer. In the database architecture, architecture must be always in terms of layers actually. So in the outer layer, so end users, the people who are actually using database, and the programmers, the people who are actually prepare such kind of databases or construct such kind of databases. So will be there at outermost layer. And then after this one, next layer will be application programs. So these application programs will be always being communicated by the programmers or users also. Users may be given some kind of data so to perform some kind of operation. Whereas programmers will be, if any modification will be there, those modifications will be, those maintenance will be done on application programs. And next layer will be database database software, actually DBMS software. So here, what are the software which could be used to done with the DBMS software is, which is used to process the queries and process the programs. Of course, we are supposed to learn something about PL/SQL also. So they will be processed, and followed by during the processing of this. Software or database software with the queries and programs, they may be used to access the stored data. So while doing some kind of operation, so we must require some kind of accessing of already stored data in auxiliary storage devices. And then followed by, so this accessing of stored data will be done through two different types of databases. One is metadata and second one is the stored database. And here, look at this. Users or programmers will be access the application programs. Application programs will be send the data to send the queries to software process queries and programs, and it will be always access the data from the databases, something like this. Okay, so this whole application programs and the database management system software and metadata followed by stored database, this whole thing will be considered as database system. Okay, so actually two layers will be there. One is database system, second one is users and programmers. Database system is again divided into So three layers. One is application programs, second one is database, so software, and third one is metadata or the actual stored database. Okay. So it is a comprehensive way of representing database architecture. While writing your final examinations, explain about database architecture. So this diagram and explanation is gets okay. There is no problem. You could get good marks only. But there is a detailed architecture also be there. I'd like to show you. So I'd like to show you the detailed architecture. This is the detailed architecture. So whomever the programmers, whomever the users, whomever the database administrators, so everything will be defined. And here, look at this. You have DML processor, query compilers, and DTL compilers. Everything will be there, and it is not supposed to be learned at this moment. While explaining something about what is that SQL, I'll come back to this particular diagram. I'll explain each and every point. So what is DML process? What is program object codes? What is integrity checker? What is command process? Everything. Let me explain during that particular time, because you could not understand what I'm speaking at this level. So because SQL is not, even you are not supposed to take even one particular exercise of SQL so far, so that you may not understand this particular thing. However, let me explain each and every point during that particular time. Okay, during explanation of so SQL and SQL sub-languages. Okay, I'll come back to this particular point again while explaining SQL. Okay, there. It's very important. You have a question also. You have a question also on this particular discussion. The discussion is data abstraction or views of data or three schema architecture. So question will be asked to you in your final examination is explain about data abstraction. So, or in some other set, explain about views of data, or in another set, it may be have explain three schema architecture. Okay, any whatever the word it might be, everything will be represents the same. Everything will be represent the same here. So what actually this particular three schema architecture will be? While any database is being constructed by any company or by you or any company, so it must be follow this particular architecture. Okay, it must be follow this particular architecture. Basically, so the name itself specifies three schema architecture. We do have three schema. So how these schemas will be? So internal level or physical level schema. This is the first schema. Second one is, of course, let me make that. So conceptual level or logical level schema. Conceptual schema or logical level schema. And then external, view 1, view 2, view 3 will be called as external schemas. All these external schemas will be connected to this conceptual schema. So this diagram is represented three schema architecture. Okay, so here we do have an internal schema, and conceptual schema, and external schema. Let me explain each and everything in a proper way. So after some time, I'd like to explain what about these two words, mapping between, what are these two words? Let me explain. So what actually been done in internal schema? Internal schema is not supposed to touch by even programmers also. Internal schema is always under the control of database administrators. It is always under the control of database administrators. It is not supposed to even touch by database programmers or database software engineers. Okay, what actually been there here? So it could be describes physical schema or internal schema always describes so how the data is being stored. How the data is being stored in what is auxiliary storage devices will be described. And second, the point which will be, it is responsible to allocate the quota. So here view 1, view 2, view 3, view n, approximately number of views are there. View in the sense user actually, end user actually. So every user does have their own quota of space. Within that particular quota only they may be used. So something like that. Allocation of so quota will be done by internal schema, and then definition or define the access paths. So how faster your data will be gets accessed. So will be also defined by this particular internal schema. Finally, internal schema is supposed to be accessed by or taken by only one person. That person name is database administrator. This database administrator is having a privilege to access this particular internal schema or physical schema. None of other people are supposed to not accept by this physical schema here. It is always trying to define how data will be, how space will be allocated, and what are the accessing speeds, accessing paths will be allocated for one particular data item. Let me show you where a SQL will be discussed by us. And secondly, conceptual or logical schema. Conceptual schema or logical schema. What about this? So it is used to define the databases. Database is normally defined by database application programmer or database administrator. Both will be done. So this definition of or designing of databases will be done by conceptual schema, and relationships between one particular database to another database will also be specified by the conceptual schema, and data security. So are there any restrictions to be operated? Just before in metadata we have seen not null, primary key or check, something like that. Such kind of restrictions will be enforced or not will be defined by conceptual schema, and then maintained by the database administrator. So this will be maintained by the physical schema, and the conceptual schema will be maintained, but not exactly completely, will be maintained by this database administrator. Of course, database programmer also maintain this conceptual schema. And finally, what exactly the point will be? Views. Otherwise, user 1, user 2, and so on, user n. What about this one? So using conceptual level schema definitions, so this particular person will be done. So if you, what do you mean by view here? View in the sense, there are, if you go to any bank, so you could identify, you could find many people who are working in front of the computers. One particular person will be always looking forward for dispatching money. Another person will be always taking money from the people. I mean teller, taking money from the people, and then he will deposit. Another person will be authentified, whether deposit or issuing money. Another person will be always looking forward for what is being happening in the particular branch of the bank. So each and every person have their own accessibilities. Each and every person have their own restrictions. So if teller will be there, teller in the sense the person who is dispatching money to the people. So he would not take any deposits. He will always issue the money. That's all. So his operation is issue the money. Before issuing, so he must communicate to his higher authority that whether so-called this particular account will be existed or not within the bank, and whether he belongs to this bank or not, will be authorization will be taken by the teller. So something like each and every person have his own activity. So those activities will be called as views here. Okay, so they have creates one particular view here, and so very important point to be remembered here is so at any point of time, at any view or at any user, what exactly he wanted to perform. So that particular operation will be done by so-called view here. All operations cannot be done by all users here. You please remember, if you are a person who is taking care about your money through the bank, in the sense, you may be perform only one operation, that is updation. If you withdraw money, so previous balance will be detected something, how much amount you are supposed to withdraw. If you deposit money, previous amount will be updated. Only updation will be done by the external user. External user in the sense the person who is using his account in any bank. And some other people will perform some kind of operations within the bank. Okay, such operations will be done by the people. And then user cannot aware what exactly the point will be. What exactly the point in the sense, how a database structure will be defined and how a constraint will be applied on one particular item of the database. These are not known by the users. They will be always simply perform only one operation, that is update operation. Even you are not having any right to operate, so insertion, deletion, or selection also not being there with you. You have only one particular operation, that is updation. So after updation, if you want to search for something, yes, you will go ahead and to apply for search. That's all. Only these two operations will be done by the external user. Okay. So these operations will be done at external level. This is called as external level here, and applying operating properly in between these two. So we have some mapping. This mapping is called as independence, data independence. And in between these two also, we have some mapping here. And look at this. So same diagram, there is no difference at all, but operation will be taking into consideration this one. So data independence in the sense, if any modification, actually what is the definition for data independence, overall definition or generic definition for data independence is, if any modification will be done at one level in the sense one schema, they should not be affected to their higher schemas. For example, internal schema does have some kind of modification. Already some structure has created. Within that particular structure, any modification will be done by other persons. That modification shall not be affected in conceptual and external. Such kind of not affecting is called as data independence. So let me repeat one more time. If any modification will be done at lower levels, they will not affected in higher levels. So look at this, internal level is a lower level. Next level will be conceptual level. The other will be external level. Okay, 3 levels are there. If any modification will be done at so internal level, they could not be took place in about 2 levels. Okay, if any modification will be taken at external level, so there is a chance to take by the below 2 different levels, but so out of external view, any other layers will be there. Those layers cannot be take such kind of modification here. Such a organization or such orientation is called as a data independence. So simply speaking, any modification will be done at lower levels. They will not be affected in higher levels. So this process is called as data independence. Normally, data independence will be defined with the 2 different types of categories. So physical data independence, and second one is logical data independence. Physical data independence will be took place at internal level or physical level. Logical data independence will be took at conceptual or logical level. Let us see what exactly they could be. Physical data independence will be done. So it is having a capacity to change, to do some kind of modifications at the internal level. They will not be affected or took any other changes in both the conceptual and external schemas. Okay, so if any modification will be done at internal level, they will not be affected. Okay, then so changes in physical schema will be always employed at actual database. Will always employed at actual database. In this particular auxiliary storage, so it will be so accepted. It will be accepted. It will be done here in internal schema. But these could not be took place in higher levels. And logical data independence will be always took place at a conceptual level or logical level. So what exactly it could be done? If there is any change which is being happening at logical level, they could not be affected in higher level, that is external level. But whatever the modification you have done here, that might be taken with this particular level. There is no problem. So one level does any modification will be done. that lowest level will be so take some kind of effect, but the highest level cannot. Okay. Then the change of conceptual schema may be affected in physical schema, but not affected in external schema. Look at this. External schema does not take any effect, but physical schema may be taken, may not be taken based on the circumstances, based on the application. Okay. And basically changes of constraints and changes of logical data independence will be done at this level. Normally logical level operations will be done by database database engineer, and internal level physical schema independence can be done by database administrator. These two people will be done here. So this is what about the class today. And here today we have covered basic definitions and the three-level architecture and the data independence. These three topics have been covered today. Tomorrow we'll go ahead and we'll look into the matter regarding to some other activities. So such as look at this. Tomorrow we'll concentrate on whatever the users, database users, which are available with the database, and okay, data independence also. Three schema architecture also been completed today. Data independence also been completed today, and what is the environment of database management system, and then how centralized and the client server architecture will be done. Everything will be discussed by tomorrow. Probably by tomorrow, unit number 1 will be gets completed. Okay. Don't go away. Let me take the attendance.